Hello, everybody, and welcome to our debate today on Alive in the Universe. I'm Catherine Heymans. I'm a professor of astrophysics at the University of Edinburgh, and I'm also the Astronomer Royal for Scotland. Now, once we saw ourselves as unique and special in the universe, but no longer, because today's fashion is to proudly believe that we are not special and far from alone in the universe. Every few months, we hear another story about the potential for life on Mars or Titan, most recently Pluto, yet no life has yet been uncovered. Meanwhile, we've got decades of listening for messages from outer space, and it's identified precisely nothing, despite there being billions of stars in our galaxy and thousands of nearby exoplanets. Might we be alone after all, and more special than we imagine? Do we search for aliens because we're scared to be on our own in the immensity of the universe, or is it just a matter of time before aliens come knocking at our door? To help me answer these questions, I have a fantastic panel of scientists with me today. Nick Lane is the Professor of Evolutionary Biochemistry in the Department of Genetics, Evolution and Environment at the University College London. His cutting-edge research explores the deepest questions around life itself, and he is the author of 4 acclaimed books on evolutionary biochemistry, which have sold more than 150,000 copies worldwide. Thanks for joining us, Nick. I'm also delighted to introduce Avi Loeb. He is Professor of Science at Harvard University. He works primarily in astrophysics and cosmology and was the longest serving chair of Harvard's Department of Astronomy for almost a whole decade. And he is now a New York Times best-selling author. And finally, I'm delighted to introduce one of my own personal heroes, Dame Jocelyn Bell Burnell. She has long been a pioneer of astronomy. She completely revolutionized the field when she discovered pulsars as a graduate student, and sort of science as a whole, particularly across the UK, has really benefited from her leadership for many decades. The question is, are we alone in the universe and more special than we imagine? And I'm going to invite each of our panelists to very briefly summarize their answer to that question. So we are going to start off with Nick Lane. Nick, are we alone in the universe?
I doubt very much that we're alone, but we haven't found anything yet. And I think there's 2 ways of going about it. We can look out and try to find evidence of life out in the universe, or we can look in, not at ourselves, but at life on Earth, and try to understand the principles that govern the emergence of life. Is it something probable in a particular set of planetary conditions? Is it something we would expect to see repeated elsewhere? What are the rules that govern the emergence of life? And I think that's perhaps the most exciting question a biologist can ask. And it's my own way as a biologist of asking these questions about life elsewhere in the universe. So very briefly, my own feeling is the kind of conditions that give rise to life on Earth requires little more than a wet, rocky planet. And there are plenty of those around, plenty of exoplanets around. You're generating the right kind of conditions, in my view, in hydrothermal vents, but lots of people would disagree with that. But that would imply that life is easy and should start almost anywhere on any wet, rocky planet or moon, and potentially in several different places in our own solar system. But then there's a strange trajectory of life on Earth, which is to say bacteria have remained bacteria. They're identifiable in the fossil record 4 billion years ago. And today we still see essentially the same things. All complex life that we know about, so plants and animals, but also things like amoeba, they share a common ancestor that was already a remarkably complex cell. We're thinking 10,000 times bigger perhaps than a bacterial cell, lots of moving parts inside, massive genomes in comparison. There was a serious shift in the scale of life, which happened about 2 billion years ago for reasons that scientists can't agree among ourselves about what was the driving force for that. My own view on this is that it required very intimate relationships between cells getting within cells for reasons to do with energetics, which I can talk about if people are interested later on. But it's basically unlikely, I would say. It happened once here. That doesn't mean to say it couldn't have happened hundreds or thousands of times. It doesn't mean to say it's not going to happen elsewhere. But I think it frames the question in a slightly more tight way, I think these same conditions would apply elsewhere, not only, but largely just as a matter of probability that life is likely to be carbon-based, it's likely to require water, it's likely to be cellular, these kind of considerations. And for those reasons, my own thought is that complex life is not going to be nearly as common as bacteria. And even when we got to complex life, if you just wind the clock back a million years or so, there weren't any humans around then. The planet was full of enormously complex life, wonderful complex life, but not anything that would become a spacefaring civilization. So we have to also question whether there is any dynamic in evolutionary biology that necessarily gives rise to the level of complexity that we are. My own feeling is there isn't, that there isn't a driving force towards that. Obviously, it doesn't preclude it, but I don't think we should necessarily assume it's out there.
Thank you very much, Professor Nick Lane. Let's move on to Professor Avi Loeb. Are we alone in the universe and more special than we imagine, Avi?
Well, I would think that it's arrogant of us to think that we are special and unique. I mean, it's true that if you go back in history, Aristotle argued that we are at the center of the world. And this view was accepted for 1,000 years because it flattered the egos of many people. And I can sort of understand that because when I watched my daughters when they were young at home, they tended to think that the world centers on them and that they are special and unique and the smartest. But once we took them to the kindergarten, they had a psychological shock to see other kids and realize that they're not the smartest kid on the block. And humanity is pretty much going the same path. And obviously, if I were to ask my daughters in the first day whether they want to be at the kindergarten or at home, they would prefer to stay at home and maintain their illusion. So one way to keep thinking that we are alone and unique and special is not to look through telescopes, just like the philosophers during the days of Galileo preferred not to look through his telescope and maintain the view that the world centers on us. And that didn't change reality. Reality doesn't really care whether we ignore it. The Earth continued to move around the sun. So we might have neighbors irrespective of whether we look through our windows. And I think scientific knowledge is always good, and it should be based on evidence. And of course, the way to figure out is to invest funds in the search. And that involves two types of searches. Rather than have a prejudice, you can search for primitive life, microbial life, which formed very early on Earth as soon as it cooled. And so it's very likely to exist on tens of billions of planets in the Milky Way alone. And the reason I say that is because we know that roughly half, plus or minus a quarter, of all the sun-like stars, based on the Kepler satellite data, have an Earth-sized planet roughly at the same separation as the Earth is from the sun. So not only we're not at the center of the universe, also what we find in our backyard, the Earth-Sun system, are quite common. You find it everywhere. And therefore we are not privileged. This is called the Copernican principle. And so we should search for primitive life. It's very likely to be out there. And most of the stars formed billions of years before the sun. And that means that if you roll the dice tens of billions of times, and most of the time you do it billions of years before us, they probably existed, and they predated us, and perhaps sent equipment into space in the form of Voyager that we sent, or New Horizons. And we might find this equipment in space. I call it space archaeology, if we search for the relics of dead civilizations that are not around anymore.
Thanks very much, Professor Avi Loeb. And finally, Professor Dame Jocelyn Bell Burnell. Is there alien life out there, Jocelyn? Are we more special than we can imagine?
20 or maybe 30 years ago, there was a survey in Britain of churchgoers. They were asked the question, would you or your faith be disturbed if life in outer space was discovered? And the answers were remarkably consistent and remarkably interesting. The answer was, no, I would not be, but I'd be worried about other members of my congregation. So I think this isn't actually the issue it's sometimes built up to be. I think if and when we do find life elsewhere, I think people will take it in their stride. It's likely to be at a considerable distance and contact would be minimal. So we're not about to be invaded or anything like that. The scene is also changing very fast. As of about now, we know of about 4,000 stars that have planets around them. And that number is doubling every 2 years. So the number of known exoplanets is growing very, very fast. At the moment, that 4,000, that's about the same as the number of stars we can see in the night sky with the naked eye, unless you live in a city centre. Mm-hmm. So the next time you see a nice starry sky, say to yourself, there's as many planets up there as there are stars. We've got some criteria, I think, about what's desirable. It's helpful to have a large moon, stabilizes the spin axis. It's helpful to have a magnetic field to screen out particles from a flaring sun. You want a sun that doesn't flare too much and certainly doesn't explode or anything like that. You want to be well away from any massive black hole in the center of the galaxy, well away from any star that would explode, and a circular planetary orbit is helpful. But even with those criteria, there are zillions of possible sites in the universe. So I think patience is called for in this game.
So now we move on to our debate. You've heard the opening pitches there, and the possibility of there being alien life out there has long captured popular and scientific imaginations. And, you know, Jocelyn there was just talking about the fact that churchgoers aren't worried about there being alien life out there, and often we refer to the sky as the heavens. But what I'm wondering is, now our world is becoming increasingly more secular. Is this idea of there being alien life out there some sort of replacement for the idea of there being a God? So, Avi Loeb, what's your thoughts on that question?
Yeah, so there is one fundamental difference between the discussion on intelligent life out there and the religious discussions, in the sense that the religious discussions focus on our actions and the fact that God responds to that in one way or another. I mean, obviously there is the philosophical God, which does not intervene, but the religious God that people often believe in is the one that does act, and or at least controls the world in one way or another. And that's not necessarily the case with the aliens. You know, they don't help us when we have a pandemic. They don't enter into our fiscal system, economic system. The other thing to keep in mind is our technologies are evolving on a few-year timescale exponentially. And what that means is that if you just go a few hundred years into the future, what we will find here on Earth throughout the natural technological development of our civilization would be unrecognizable to us now. It would look like magic. It's as if you showed a cell phone to a caveman. And obviously, something that looks like magic resembles those miracles that are reported about in the Old Testament, for example. So you can imagine that a contact with another advanced civilization, simply older than we are, just older. If their star formed billions of years before the sun and they had 1 billion years to develop their technology, they would do things that we cannot fully understand. And they could, in principle, I can imagine if they have a theory of quantum gravity that we don't possess at the moment, they might have a way of producing a universe, a baby universe in the laboratory by irritating the vacuum. And just think about it. This is exactly the story about God that created the universe. And obviously they can probably produce synthetic life because we are getting close to doing that in our laboratories. So creating life, that's another quality that was assigned to God. And so in that sense, the scientific sense, I would say that we might acquire capabilities in our future that others already have, and that would look to us now as divine qualities when we meet them, when we see evidence for them.
So Jocelyn, Avi's saying there that aliens could potentially have the same powers as what a godlike ethereal being would have. What's your thoughts on that?
I have real problems with this question. I don't understand where it's coming from. I do not see the connection, the link between the two halves of the sentence. So I'm sorry, I'm really at a loss to understand what this question's about.
Yeah, I think I agree with you there as well, Jocelyn. That there's the sort of the scientific question of could there be life elsewhere on the planet, and there's the more sort of religious question of is there some sort of higher being across the whole universe. But I think what we're thinking about here is, are people traditionally, people have looked to there being a god, a higher being, and is now our world becoming more secular? Are people starting to look out into the universe for something that is like a god out there?
In which case they're dependent on the scientists for mediating that god to them, which is an interesting role for scientists.
Exactly. Nick, have you got any thoughts on this question?
I mean, I suppose it's a more pessimistic view than Avi's. I mean, why do we want there to be a God in the first place? You know, a lot of people will believe in God. I personally don't, but I think as humanity, we do have a deep yearning for an authority figure, for a source of order, for an explanatory principle and a guiding force, I suppose. And perhaps that's faltering, at least in places like Britain or the US. And perhaps that means, you know, if we are in charge, that's quite a frightening prospect. We know how useless we are, really, in terms of, you know, we are destroying the planet. We are liable to destroy ourselves. This is very often a question for, you know, what happened to other civilizations out there. Is there a trajectory towards self-destruction? And if we only look at ourselves, then the answer is alarmingly close to being yes. So perhaps there is a yearning to find an extraterrestrial intelligence that can guide us through the universe. Perhaps there is some hope that that's out there. I don't really know. I mean, the question started out: Are we special in some way? I personally, as a biologist, I don't see us as in the least bit special. And in terms of our response to aliens, again, look at the way we treat the rest of life on the planet, and we'll understand how we're likely to respond to aliens. And also, again, you know, Jocelyn alluded to it. There's so many different points of view in terms of what would happen if we did come across aliens. Everybody would respond in their own different way to that. I don't think it's possible to generalize, really. So the only other thing I'd say is that, in my mind at least, we have created the image of God in our own image. So it's a white bearded old man. Maybe that image is shifting now, but we also tend to invent aliens in our own image as well. And I think a lot of us, I love, Star Wars or Hitchhiker's Guide to the Galaxy or whatever it may be. I love the idea that there's a thriving universe full of alien beings out there, but they all look remarkably similar to us. And the reality is highly unlikely to be anything like that. So I do think there is also this urge to create an authority figure or superhuman figures somehow in our own image.
Well, let's dig deeper into that then, and let's sort of think more about the science of, could there be alien life out there? Now, Nick, you are our biochemist on the panel. How easy is it going to be to create life on one of these many different exoplanets that Justin was telling us have already been discovered?
My own feeling is it's not that difficult. That's not to say we can do it in the lab right now. I personally think we're a way away from doing that in the lab, but I do think we can understand a lot of the principles already, and I think we're making fast progress at the moment. The difference is that what we can do in the lab are single experiments, and those single experiments are a tiny part of an overall problem. And what we have on a planet is an entire planetary system with millions of years and entire seafloors at our disposal. So it's a laboratory on a scale that we cannot begin to emulate in the lab. So I don't think it's a trivial thing to create life. I think personally that we're still a long way from doing that in the lab, at least in the way in which I would understand it. But I think conceptually we're making progress, and certainly from my own point of view, I would expect to see bacteria or cells of that level of complexity on almost any wet rocky planet. And in some sense that's
bacteria and cells are quite different from the ethereal things that Avi was hoping might
I think that's going to be
universes in
rarer.
Their own sense.
I think that would be much rarer, but that's not to say they're not out there. That's simply to say that there isn't I think we again have a wishful thinking that once you've got the conditions for life, that there will be a trajectory in evolution that starts with bacteria and ends up with superhumans. And I don't think that is true. I think the likelihood is that there would never have been humans on Earth. I think the likelihood is for most wet rocky planets that you would never get to the level of complexity of an amoeba. But still, there are many, many billions of options of other planets which will have gone beyond ours. And I think, as Jocelyn said, they're going to be a long way away.
So Avi, I think you're a big fan of there potentially being very highly intelligent life out there. Do you want to tell us a bit more of your thoughts on that one?
Yeah, the one thing I learned after studying the universe for decades is a sense of modesty. Mm-hmm. That we are not particularly intelligent ourselves. If you read the morning news, right? We fight each other. We try to feel superior relative to each other. That's not a sign of intelligence. A sign of intelligence is cooperating towards a better future. And if I open recipe books for cakes, let's say, and I look inside, I find that out of the same ingredients, you can get very different cakes depending on how you mix them, how much heat you apply, at what time you apply the heat. And what's the chance that the chemicals that existed on early Earth created the very best cake possible ourselves? I would say very small. I would argue that we should be modest and search rather than have a prejudice and be very proud of ourselves, because whenever we did that in the past, whenever we claimed that we are privileged, unique, and special, we resembled my daughters when they went to the kindergarten. So I would argue for a sense of modesty. Now, the other thing is that it's possible that life has many different forms, not the way we have it here, but it can, for example, exist in other liquids, not just water. And of course, the best way to expand our imagination is by doing laboratory experiments. And one of my colleagues at Harvard is Jack Szostak. He won already a Nobel Prize, but he's working on his second. He's trying to produce synthetic life in the laboratory. And he told me that when he started a decade ago, he thought that it's quite difficult to arrange for the conditions that will create life on Earth, on early Earth. But now that he worked on it for a decade, he's much more optimistic that random processes could have led to where we are. And it's not particularly rare, and he is getting close to producing synthetic life in his laboratory. So given that, I would argue that we should be open-minded. We should not think too highly about ourselves as being the pinnacle of creation. Instead, we should open our eyes and search. And what I mean by search is that this subject should become the mainstream of astronomy. Searching for intelligent life is a reasonable thing to do, as much as searching for the nature of dark matter or searching for gravitational waves. Tasks that were funded at the level of $1 billion so far. And the search for intelligent life, received 1,000 times less funding.
So, Jocelyn, when you made your discovery of pulsars, I understand that it was entitled LGM for Little Green Men. So Avi's saying we need to have more funding to go and look for these things. I mean, how would we go about trying to find evidence for alien life? Avi's convinced these complex life forms could be made, and Nick will come back to you to see whether you agree with him. But how would we go about trying to find evidence for these little green men?
Most of the work so far has focused on radio wavelengths. So, looking for their television signals or their mobile phones or things like that. That is assuming that they are reasonably similar to us. But I think that's probably a reasonable place to start as well. How would aliens know we existed? It would probably be through our radio signals inadvertently sent. They might pick up a spacecraft or two, but that's very much needle in a haystack. So I think equally for us looking for them, radio is often the best wavelength, and it's where most of the effort has been focused so far. And of course, as we get bigger radio telescopes, there's perhaps more chance. But equally, as we get bigger telescopes, we're getting bigger data rates. And the data is going to be analyzed by computers before humans even get to look at it. So then the question becomes, have we programmed the computer that it would reject a signal from an alien? And the answer is yes, probably we have so far. Whether we could see biological trace, or they could see biological tracers in our atmosphere, they might be able to, if they're reasonably close and they have good telescopes and spectrometers. Yeah.
Nick, let's go to you. Our biologist. Is that a way forward? Are there going to be biological traces in the atmosphere?
If there's a thriving planet, yes, you would expect to see them. Whether we can currently detect them at the moment, we're on the point of being able to do that. I think there's a deeper problem here, which Avi was getting at, which is to do with what should we be looking for. And I'm coming at this as if you like, an earthbound biologist. I'm looking at carbon-based life. I'm thinking about life as I know it. And I don't dispute for a moment that there can be all kinds of other different forms of life out there, perhaps limited only by the imagination. So the question is, well, if it becomes science, how do we constrain the imagination to ask questions of what's out there? And the way in which I can do that, I think, is to ask, well, why is life the way it is here? Are there fundamental reasons for that? Or could it have been completely different, in a different setting, with a different fluid than water, with something other than carbon, whatever it may be? Are there good reasons why it's this way, or could it be some other way? There's two ways then of doing science. We can try to build from what we know and think in fundamental principles going up. And again, as Avi said, we must be modest, because the good thing about lab work is you find that you're wrong on your specific predictions every day. And it keeps you modest. All scientists know, or all good scientists know, they're wrong about a lot of the stuff most of the time. And I think that's really important to convey. So I think that's why exploration has always been one of the most important aspects of science, and an open-minded exploration that says, okay, well, I think things are like this, but I accept that they could be like that. So how are we going to test it so that we don't just have blinkers on and look in one particular direction and fail to see what's obvious just because nobody's actually looking in that direction? So
we had a visitation in the solar system a little while ago by Oumuamua. Did I pronounce it right, Avi?
Very well, yeah.
Now, was that an alien civilization exploring, or was it just a lump of space rock that happened to be passing through the gravitational field of our solar system? Avi, I know you have opinions on this.
I have a book that came out a few months ago called Extraterrestrial, and I have another one, a textbook of 1,000 pages coming out in a month by Harvard University Press about the search for both primitive life and intelligent life, where I discuss these issues. But very briefly, this object didn't look like any comet or asteroid that we have seen before. It was the first object from outside the solar system that we spotted near Earth. And it was flat in its shape based on the analysis of the reflected sunlight. It was pushed away from the sun by some excess force that declined inversely with distance squared. And there was no cometary tail coming off it. There was no gas around it. So I simply suggested that maybe it's a very thin object, like a sail being pushed by reflecting sunlight. And there was such an object that we produced, a rocket booster that was discovered in September 2020, called 2020 SO, just to demonstrate the concept. At any event, I wanted to highlight the fact that, as Jocelyn mentioned, over the past 70 years, we've been searching for radio signals. And that is just like trying to speak on the phone with a counterpart, and you need the counterpart to be alive. And in my view, most chances are that most of the civilizations, technological civilizations that existed, are dead by now. They had a short window of opportunity where we could have communicated with them, but they are not around. And so the best method to find evidence for them is to look for relics that they left behind, equipment they sent into space, and the discovery of Oumuamua is a wake-up call. And of course, the best way to figure out whether an object is artificial or natural, is just like when you go on the beach, you see most of the time rocks that are naturally produced, but every now and then you see a plastic bottle. And so what you want to do is, if you get an alert of an object as weird as Oumuamua was, you want to send a spacecraft with a camera that will intercept its trajectory and take a close-up photo. And, they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had a close-up photograph.
Now, ESA have commissioned something called the Comet Interceptor, which I'm super duper excited about, because it's going to be launched before it knows where it's going. And then when a comet or something useful comes in, then it can set off to make a trajectory. So would that type of instrument work for your goal to take a photograph of an extraterrestrial passing through our solar system?
Yes, definitely. And there was OSIRIS-REx. That's another mission that actually landed on the asteroid Bennu not long ago, and took a sample from it, took a photograph and a sample. It looked like a rock, and it will bring back the sample to Earth in 2023. So just imagine us landing on an artificial piece of equipment, reading off the label made on planet X, and importing the technology to Earth. It could represent something in our future. The experience would be just like getting access to a cell phone long before it's offered to the public, and enjoying all the features that it gives you.
Now, Jocelyn, you described this sort of trying to sort of search for things that have been set out, a little bit like a needle in a haystack. What were your opinions on what Avi's saying here?
I believe there's been a second visitor from another solar system. I think Oumuamua has had a successor, one that we haven't seen nearly as well, and we don't have pictures of it. But an object came by, I think, in 2020. I'm not
2019. Yeah.
2019.
Yeah.
Yep. And its trajectory means it must have come from another solar system. So that's the nearest we've got to kind of direct contact, and it's pretty indirect. But it's interesting that we're now in a position to be able to pick up some of these visitors from other solar systems.
But you talk about visitors. I mean, I think of these things as just lumps of rock. There's no, as far as I'm concerned, it's unlikely that there's any sort of complex life on these things. Otherwise, they would have said hello.
I think they probably are just lumps of rock, maybe not even that solid lumps of rock, but yep, inert bodies, shall we say, uninhabited bodies, unplanned bodies. Yeah.
When you talked about there being all of these exoplanets out there, and our best guess of the universe is that it's infinite in space and time. So, what's our best way to try and, Avi wants to see what's going to come into our solar system. You were talking about radio signals. Do we need to go out and target more exoplanets? There's this phrase. Do you want to explain what a Goldilocks planet is, Jocelyn?
So yeah, we've got all these exoplanets, but only a fraction of them are going to be suitable, we think, for a carbon-based life. In some cases, the star will be too hostile, too much sort of cosmic rays and things like that from the star that would break up the relatively fragile molecules we need to make life. Sometimes the planets are too close or too far away, even if the star is quiet, steady. So there's a lot of factors you have to weigh in doing these sums. But nonetheless, our reach is gradually extending with more and more telescopes. So we're sampling more of the universe. That's undoubtedly true. And particularly with all the work done to discover exoplanets, it's a very big area of astronomy now. So I think there probably would be some exoplanets that we could target in the not too distant future, and just have a watch on them, looking for stray radio signals or things like that.
And Avi wants us to go and explore. I mean, is that at all feasible? Could we even travel to these exoplanets? Or just the distance is far too extreme?
First of all, we couldn't, but could we send satellites? Could we send probes? And we could, but you have to be very patient. This exploration's in danger of taking several lifetimes, and human memory is probably not good enough to provide that kind of continuity. So I'm not convinced that we can go explore. I think we can listen. I think that's the main thing.
All right, so Nick, let's imagine that we found the perfect Goldilocks planet. It looks just like Earth. It has water, it has land. You started at the start talking about these laboratory experiments. I didn't get a sense from you how likely it is.
I think it's very hard to say how likely it is. I mean, all we can say for sure is that all complex life is composed of one particular cell type, this eukaryotic cell, and that that has a common ancestor, and that common ancestor by definition arose once. That's not to say that complex life didn't arise on hundreds or thousands of occasions on Earth and vanished without trace. That's perfectly possible, but there's no evidence for it. And so we should entertain the possibility that it's genuinely difficult as well. So I'm not necessarily advocating that, but the question then is, well, are there constraints on bacteria that keep them bacterial? In effect, they have searched far more genetic informational sequence space than we have, and yet there's something which has kept them small and simple in their morphology. And I personally think the explanation for that lies in the way in which cells generate energy. Cells generate energy effectively by having an electrical charge on the membrane. And that electrical charge, it's used for specific purposes like generating ATP or fixing carbon dioxide. I personally think it probably goes a lot beyond that. I suspect that it's part of what forges the identity of a cell, if you like, the self of a cell, that it's determined by the electrical fields on the membrane. That's a bit of a way out view, I suppose. But the question is, does life have to be that way? And there are some indications to my mind that yes, it's perhaps predictable that life ought to be cellular. Life ought to have something which is unifying it as an organism. And if all of that's the case, then if we apply that to what happened at the origin of the eukaryotic cell, well, it was effectively one cell got inside another cell and imported this electrical charge internally, and it doesn't seem to be so easy for that to happen. Now,
so you can't reproduce that in a laboratory, or?
No one's ever done so. People have tried. I would love to try, but it's one of these projects that would probably take 10 years and would probably fail, and it's difficult to get anyone to fund it. But it's the obvious thing to try to do. And it's not necessarily so difficult. You know, there's always the very simple explanation that it happened once because whenever it happened again, the guys who were out there already just ate all the newcomers. You can't ever disprove that kind of an idea. So it's very difficult to put a probability on it. But I think the idea then to take it to the other extreme and simply say life starts and then it becomes intrinsically more complex, it's not sustained by biology as we know it, and it's not sustained by the history of life on the planet. And so I think the interesting question to me is, well, is that just an accident? Is it just a historical artifact, if you like, of what happened on Earth? Or is there something more fundamental about it? And I think it's too early to say what the answer is to that, but my own inclination is to think that there are fundamental aspects to cell evolution that mean simple life is likely to be common and more complex life is likely to be less common, and that those principles are likely to govern carbon-based life elsewhere in the universe. And that, at least, I think, would make it, we've got tens of billions of wet, rocky exoplanets in the Milky Way alone. What proportion of them would produce life? Jocelyn was saying there's issues with the moon. There's issues with the Goldilocks zone. One of the most likely places in our own solar system will be Enceladus, way outside the Goldilocks zone. But it's wet. It's got a large ocean on it, and it would be my favored place for looking for life within our own solar system.
What I think is that we should be guided by evidence rather than by prejudice, because nature's imagination is far greater than ours, especially in the context of life. And humans tend to speculate quite a bit and have a prejudice and convictions. But the one thing we learn from science is that we should pay attention to evidence and be guided by evidence. And the way to find evidence is to search. And so the practical question is whether we should just search for primitive life or allow ourselves, maybe at a level of 10% of the budget, to search for intelligent life, because currently it's not being done. And it goes even farther, because there is Fermi's paradox that was formulated 70 years ago by Enrico Fermi, a very famous physicist. When he had lunch at Los Alamos with his group, he said, "Where is everybody?" And to me, that question is very presumptuous. It reminds me of the friends of my wife. When I first dated her, she had friends that were waiting for Prince Charming on a white horse to come and make them a marriage proposal. And it never happened. So they compromised. And why should we believe that we are sufficiently interesting and privileged to have those aliens come to us and have a party in our backyard and show themselves in a way that would be extraordinary and convincing? We need to go out and search for them. We are not particularly interesting to them. I think we are as common as ants are on a sidewalk. When you walk down the street, you don't pay special respect or attention to each and every ant. And so my point is, practically speaking, I'm trying to be as practical as possible, not have a prejudice, not have percentage probabilities in our head, but rather explore. And the way to explore is to invest funds in instruments and telescopes that look out. And as I said, we should increase the funding for this frontier by at least a factor of 1,000.
How long are you prepared to wait, Avi? Let's say the governments of the world give you as much, an infinite amount of resources, so you could build whatever technology you wanted. How long would you be prepared to wait?
My lifetime. If you look at the search for dark matter, we invested the kinds of amounts of money that I was talking about, looking for suggestions from theorists about weakly interacting massive particles, axions. We haven't found them. Does anyone complain? No, because it's part of doing science. So, my point is, without searching, you will not find anything wonderful. It's a self-fulfilling prophecy. And I believe that if we do search, that within our lifetime, we might find it. In 1939, Winston Churchill suggested searching. He thought that it's a wonderful, exciting opportunity to search for intelligent life out there, or life in general. But he was drafted to become Prime Minister of the UK and fight the Nazis. And his essay was never published. But if instead of investing those resources that were wasted on the Second World War, that was driven by racism and wasted just for the US $4 trillion and killed 75 million people worldwide. And, if all these resources were dedicated to Churchill's original vision from 1939 to search for life, we would have known the answer by now.
Jocelyn, if we stopped all nuclear weapons building and put all of our money into searching for extraterrestrial life, how long would you be prepared to wait for? How long before you say, no, there's nothing out there?
I suspect scientists wouldn't put a limit on that, to be honest. I think a limit might be put is what fraction of resources go on it. So for example, with next generation telescopes, things like James Webb Space Telescope, which hopefully will launch fairly soon, it's going to spend some time studying the atmospheres of some rocky exoplanets to see if they can get any evidence, focusing on ones that are sort of Earth size or a bit bigger. I wouldn't want, I don't care about this issue sufficiently that I want mega resources devoted to this only, but if it can be done on the back of other genuine scientific searches, that's, I think, the best way to do it. It requires a bit of imagination.
Yeah, would it be revolutionary? Like you say you're not so interested in this question, but isn't it, it's one of the biggest questions that there is. Are we alone? Isn't it, Avi's saying this should be the thing that we really invest in because it's such an important question, but you don't seem so, it's not high up on your priority list.
Given the difficulty we've had finding them, I don't think they're very close or an imminent threat, is how I would describe it. So yeah, it's an interesting question to resolve one day, but I don't personally give it huge priority. Yeah.
Nick, how about you? On a sort of a biology side of things, I'm about to give you all the resources in the world to go out and answer this question. How long would you wait? What would you do?
I think we wait as long as it takes, really. I think, I extolled the importance of exploration and keeping an open mind. I would tend to agree with Jocelyn. I think the likelihood is we will not find anything very quickly. And the likelihood is it will be ambiguous whenever we find something and people can argue about it interminably. But I would agree with Avi that a lot of science is a bit too conservative, that we tend to fall back on what we know, and we shouldn't be doing that. We should be bold. We should be asking the question. The right way to ask questions is something to argue about and disagree about, perhaps. But to back away from them because we somehow don't even want to look in that direction seems to be very small-minded and not what science is about. I think what science is about to me is exploration. It's about understanding the world, about exploring the universe, about trying to see what it's made of and how it came to be this way. And that's very much a search. And we can be informed by what we know, but we shouldn't be absorbed with what we know because we don't know what 95% of the universe is made of anyway. We should be very humble in front of it. All we know about life is the life that we know on Earth. It may or may not be this way somewhere else. We can try to study it and try to understand the principles, but the chances that we understand them correctly is remote. So we have to keep an open mind and look.
So Nick, even though you're not religious, I would say amen.
Thank you so much, everyone, for joining us today to discuss alien life.